In this lesson, we're going to look at how to use interval notation. And interval notation is what we see usually when we've solved an inequality. So, when we solve inequalities, the solution is not just one or two numbers like we've seen with our equations, but it's a whole range of numbers. Like the solution might be everything between 3 and 8, or all the numbers that are bigger than 2. So we can't just list all the numbers because there's an infinite number of them. And there are three ways that we can represent solutions to inequalities. We can use set builder notation, or we can graph on a number line, or we can use interval notation. And in this example, we're going to graph several inequalities and write them in both set builder and interval notation. So the first one let's look at is x is less than 4. Okay, if x is less than 4, if I draw a number line and put a 4 on it, the numbers that are less than 4 are all to the left of 4. So I will shade the left end of my number line. Now look, I have an arrowhead that indicates my shading continues forever, and this other arrowhead indicates that the number line continues forever. So I really kind of need both. And now I have to decide whether the 4 should be shaded or not. And if you think about it, our expression says x has to be less than 4. It does not say that x can be equal to 4. So the symbol that we will use to show that x can't be equal to 4 is a round parentheses. I know that if you took Algebra 2 in high school and you used some books, still use the notation of an open circle or closed circle. So the parenthesis is equivalent to the open circle, if you're familiar with that. And if you're not, don't worry about it because we won't be using it. But now let's look at set builder notation. And set builder notation is very simple. First, it starts out with a set of curly braces, and then it puts the variable in question here, and then it just puts the inequality. And the way you read this is you say our solution is the set of all x's such that x is less than 4. That's what that means. The set of all x's such that x is less than 4. So that tells you that it includes 3 and 3.5 and 1.2 and 2.7 and 0.98 and everything that's less than 4. Now for interval notation, it's helpful if you imagine the line extending forever in each direction. So we say that the left end of the line goes toward negative infinity, and we say that the right end of the line goes toward positive infinity. Now the interval notation gives the starting point and stopping point of the shading in order from left to right. This shading starts at negative infinity because it could start as far to the left as you can imagine. So negative infinity, and then it stops at 4, and you see here that I have a round parenthesis, and that parenthesis matches this one that's on my number line. So this is what's called interval notation because it describes the starting point and the ending point of an interval. The left end and the right end. And here's another inequality. X is greater than 6. So for our graph, we will put a 6 on our number line, and this time, because we want to graph the numbers greater than 6, we will go toward the right, and again, because x cannot be equal to 6, I'll use a round parenthesis. And now my set builder notation, I have the set of all x's such that x is greater than 6. So what goes in the box here, what goes inside the curly braces, is simply your inequality restated. Now the interval. Again, we get negative infinity and positive infinity on each end of the line. And this time, if I think about the left starting place and the right ending place, the shading starts at 6 and it goes to infinity. So my interval is from 6 to infinity. And now for x is less than or equal to 3. I have my number line with 3. And again, I shade to the left because the numbers that are less than 3 are to the left. But this time, x can be equal to 3. So I need to put a bracket to show that x can be equal to. And the bracket only shows up if we have the or equal to line. And that's the other, this would be equivalent to the closed dot if you're used to the open dot, closed dot notation. And so the parentheses means it cannot be equal to the number, and the bracket means x can be equal to this number. So now our set notation is all the x's, the set of all x's such that x is less than or equal to 3. And our interval notation will be from negative infinity to 3. Bracket, because this bracket matches this one. Now you might notice that I have a round parenthesis here, and you might have been expecting a bracket because you might think that they need to match, but they do not need to match. So the deal is, infinity never gets a bracket because it's not truly a number, it's more of an idea. It's like tomorrow, it's always out there and you can't ever get to it, so it can't have a bracket because you can't truly include it. Never use brackets for infinity. And for one last one, let's do x is greater than or equal to 8. So I will shade to the right of my number line, and the bracket is there because I have the or equal to bar. And now the set notation is the set of all x's such that x is greater than or equal to 8. And the interval will be bracket 8 to infinity, and round parentheses there. Okay, now we're going to do it in a little different order. I'm going to give you the interval, and we're going to then write the set builder notation and the graph. Okay, here is our first interval, from 1 to 6, including 6. If I draw my number line and I put both 1 and 6 on the number line, all the numbers between 1 and 6 are right here between 1 and 6. So the 1 gets a parenthesis, you can tell from the interval, and the 6 gets a bracket. And now our set builder notation will be all the x's such that x is between 1 and 6. Now, if I write down the x in the middle and the 1 and 6 on each end, then I can say 1 has to be less than x. But x has to be less than or equal to 6. And you can see the round parenthesis gives me a less than sign, and the bracket gives me a less than or equal to sign. Because the x is in the middle, the smallest number is on the left, then anything in between there is in the middle, and the biggest number, 6, is on the right. Now, these are always less than signs, and we will always use either less than or equal to. We'll never have greater than signs on this kind of notation where we want to trap x between two endpoints. Alright, here's another one. From negative 4 to 3, including negative 4. Let's draw our number line, and we'll put our two numbers on it. We'll shade everything between negative 4 and 3. We'll put a bracket on negative 4 and a parenthesis on 3. Then, for our set builder notation, we're going to put x in the middle. Negative 4 has a bracket, so we'll put less than or equal to. 3 has a parenthesis, so we'll put less than. And this says that negative 4 has to be less than or equal to x. And that's true because negative 4 is the smallest thing on our graph. And x has to be less than 3. So all these numbers fit that description where negative 4 is smaller but 3 is larger. And here's negative infinity to 3.5. So I've graphed my 3.5, and now the numbers that are between negative infinity and 3.5 are to the left here. And because I have a bracket on my interval, I'll need a bracket on my number line. And then the interval notation will be all the x's such that x is less than or equal to 3.5.